Everyone talks about Mars, right? The red planet, humanity's next big step. But what if there's a darker, colder, maybe even more fascinating world out there waiting for us? Today, we're taking a deep dive into Saturn's largest moon, Titan. We're going to unpack why some people think it might actually be a better bet for human colonization than Mars. We'll look at the unique advantages, but also the really big challenges. Our sources for this are pretty cool insights from Insane Curiosity on YouTube, some discussions on the NASA Spaceflight Forum, scientific papers from places like the Journal of Astrobiology and Outreach, and ArcGIS, plus NASA's own strategic reports.
Yeah, and what's really compelling here, I think, is we're not just talking about what Titan is, but really digging into the why. The science and engineering nuts and bolts that make it potentially habitable or not. We'll cover everything from its huge atmosphere, those weird liquid lakes, even this idea of humans maybe flying with wings there. So what does it all mean for our future out there in the cosmos?
Okay, let's get into it. Titan might just be the solar system's best-kept secret for habitability. I mean, forget those huge, bulky pressure suits you see astronauts wearing.
That's exactly right. Titan has this incredibly dense atmosphere, mostly nitrogen. It's actually over 50% denser than Earth's at the surface, and that thickness provides a natural shield against cosmic radiation. That's a massive advantage over Mars or the Moon, which basically have no protection. So you get this double shield, Titan's atmosphere, and Saturn's huge magnetosphere. It makes things much safer and potentially cheaper, too, because you need less shielding on habitats and spacecraft.
Right, so that thick atmosphere is not just for protection. It changes how humans could actually move around, doesn't it?
Absolutely. Because the pressure is so high, about 1.5 times Earth's sea level pressure, you wouldn't need a traditional rigid pressure suit. We're talking lighter gear, more flexible. Really, you just need warmth because it's freezing. And an oxygen supply. Imagine the mobility. Way easier to move around compared to, say, Mars.
Okay, so mobility's better, but what about the atmosphere itself? Is it useful?
Oh, incredibly useful. It's over 98% nitrogen. That's the richest nitrogen atmosphere we know of anywhere besides maybe Earth itself, though Titan's is denser. Nitrogen isn't just filler gas. It's essential for creating breathable air. You mix it with oxygen. You can use it to make fertilizers for growing food, industrial chemicals, even rocket propellant. Some people even talk about it being useful for future terraforming efforts, although that's way down the line. Compare that to Mars. Its atmosphere is thin, mostly CO2, with only about, 2.6% nitrogen? A huge difference.
And nitrogen's just the start, resource-wise. Get this, Titan has actual lakes, rivers, seas, but they're filled with liquid methane and ethane.
It's not science fiction. Cassini confirmed it back around 2008. The data suggests there's hundreds of times more liquid hydrocarbons on Titan than all the known oil and natural gas reserves here on Earth.
Wow, hundreds of times. So what's that actually mean for a colony?
Well, think about it. It's a massive, easily accessible energy source just sitting there. You can use it for power generation, for fuel, for industrial processes. You can also use those hydrocarbons to make plastics, polymers, lightweight, durable materials for building habitats. This drastically cuts down on needing to ship everything from Earth, which is incredibly expensive. It really boosts the idea of self-sufficiency, and Mars just doesn't have anything like that as far as we know.
And what about where Titan is? Being in the Saturn system, does that help?
It certainly seems to. Its neighbor, Enceladus, is really interesting. That little icy moon is constantly shooting out geysers of water vapor, ice particles, and even organic molecules. So it could be a relatively easy-to-reach source of water ice. Easier, perhaps, than mining subsurface ice on Mars. Plus, being there makes Titan a great base camp for exploring the whole Saturn system, maybe even searching for signs of life on Enceladus, and just generally expanding our understanding of these outer worlds.
Okay, Titan's sounding pretty good, almost too good. There have to be some major catches, right?
Oh, absolutely. Let's not sugarcoat it. There are some very real, very chilling challenges.
I see what you did there.
Yeah.
So the cold.
Yeah, the cold is the big one. Titan's surface averages about minus 180 degrees Celsius. That's minus 292 Fahrenheit. It's one of the coldest places in the solar system. Everything needs advanced insulation and heating. Habitats, equipment, rovers, materials can get brittle and just fail at those temperatures. And yeah, while the suits don't need pressure, they need serious heating systems to keep people alive.
And just getting there must be a nightmare. It's so far away.
It's a huge distance, over 1.2 billion kilometers from Earth. That means long trips, years long, which requires incredibly advanced spacecraft, life support that works for ages, and the costs are, well, astronomical.
Right. And the distance ties into another problem, doesn't it?
Yeah.
Energy.
Exactly. Being so far from the sun, plus having that thick, hazy atmosphere, means sunlight is incredibly weak on Titan's surface. You only get about 1% of the sunlight intensity we get on Earth, and then only about 10% of that actually makes it down through the haze. So, solar power. It's pretty much a non-starter for any serious energy needs. You'd need absolutely enormous solar arrays, like ridiculously huge. One estimate suggested covering an area almost the size of the US to power a similar population.
Wow. Okay, so no easy solar power,
Yeah.
and that dim light and cold must make growing food almost impossible.
It's a massive challenge, yeah. You'd need sophisticated greenhouses, artificial lighting, heating, everything tightly controlled. It's theoretically possible, but it demands advanced tech and careful resource management. Mars honestly looks easier in comparison for growing plants with its CO2 atmosphere and slightly less extreme temperatures. We'd need serious research into crops that could survive, or maybe engineered microbes that could convert local stuff into food.
And another human factor, gravity. What's that like?
It's low, really low. Only about 0.138 grams, which is roughly 14% of Earth's gravity. That's actually a bit less than the moon's gravity.
Okay, so flying might be possible, but what does that low gravity do to the human body long term?
That's a huge question mark. We know from astronauts in zero-G that low gravity causes bone density loss, muscle weakening, immune system issues. Exercise helps, maybe weighted clothing, but the long-term effects, especially for people living there for years or even being born there, we just don't know. There's speculation that kids born and raised on Titan might never be able to adapt to Earth's gravity if they came back.
So pulling all these challenges together, building a real self-sustaining colony sounds incredibly tough.
It is. It faces huge technological hurdles. Building infrastructure that can withstand the cold, generate power, produce food, protect against potential hazards. It's complex and very resource intensive. You'd absolutely need advanced robotic missions first to scout, prepare sites, maybe even start building before humans even set foot there. And the colonists themselves would need an incredible range of skills.
Right. It is a monumental task. But, humans are pretty good at figuring things out when we put our minds to it. So let's dive into some of the solutions people are proposing.
Yeah, absolutely. And the key, looking at the bigger picture, really seems to be using what's already there, in situ resource utilization, ISRU, and having closed-loop bioregenerative life support. For energy, since solar is out, nuclear power is often seen as, well, a life or death necessity, as one source put it. Things like RTG's radioisotope thermoelectric generators using plutonium-238 could provide power for decades. There's even talk of potentially mining radioactive elements from Titan's deep interior, though that's very speculative.
Okay, nuclear is probably essential.
Yeah.
But are there other options using Titan's unique chemistry?
Yes, and this is where it gets really interesting. There's potential for chemical energy. For example, reacting hydrogen with acetylene, which is made high up in Titan's atmosphere by sunlight, releases a good amount of energy, about 376 kilojoules per mole. Or reacting hydrogen with the atmospheric nitrogen, that gives off energy too, about 92 kilojmole. Now, just burning the methane and ethane isn't very efficient because there's no free oxygen in the atmosphere. But you could use a nuclear reactor to power electrolysis, splitting water perhaps from Enceladus to get oxygen. Or maybe, further down the line, use genetically engineered plants or algae to produce O2.
And what about those massive hydrocarbon lakes? Can we get power from them directly?
Potentially, yes. Hydropower is an option. Think dams, but using liquid methane instead of water. Because Titan's gravity is lower, you wouldn't get as much power as a similar setup on Earth, maybe 9 megawatts compared to nearly 100 for a similar flow. But the sheer volume of liquid in places like Kraken Mare, the biggest sea, is immense. It could theoretically sustain power generation for tens of thousands of Titan years. Plus, Saturn's gravity causes strong tides in those seas. You could potentially harness those tidal flows, especially in narrow channels like the throat of the Kraken, for a reliable power source.
Okay, hydropower, chemical power. What about wind? You wouldn't think there'd be much wind there.
Down at the surface, yeah, winds are pretty slow. But if
Okay.
you go up higher, maybe around 40 kilometers altitude, the winds get much stronger, up to 20 meters per second. So people have proposed using tethered balloons or dirigibles carrying windmills way up there. Because Titan's atmosphere is so much denser than Earth's, about 5 times denser at that altitude, you could potentially generate hundreds of megawatts of power this way.
Fascinating. So, with power options sorted, maybe, how do we actually build places to live?
Well, one really cool idea is building habitats inside the mountains, which on Titan are made of water ice. You could use hot water drills to melt tunnels and caverns inside the ice. These would be naturally shielded. The trick is you'd have to keep the inside temperature below freezing, maybe around -3 Celsius or 26 Fahrenheit, to keep the ice structure stable. So you'd need systems to constantly pump excess heat out. Another idea is floating habitats on the methane lakes. Imagine large cylindrical structures, maybe transportable by something like SpaceX's Starship. These could have their own integrated power source, like an RTG, using the heat to boil the surrounding methane to spin turbines and generate electricity right there, without needing long, vulnerable power cables stretching across the landscape.
And what would we build with? Can we use local materials?
That's the goal. Using local resources is key for long-term sustainability. The methane and ethane can be processed into plastics and polymers. Think lightweight building materials, insulation panels. People have experimented with using simulated moon and Mars dust regolith as aggregate for concrete. You could potentially do something similar with Titan's ice or crushed silicate rock mixed with hydrocarbon binders. This fits that Class 3 habitat strategy building almost entirely from local materials.
Okay, so we have ideas for power and structures. But what about the human element? Dealing with low gravity, isolation, maybe over generations.
Yeah, that raises some really important questions about long-term adaptation. The low-gravity health effects are a big concern. Exercise will be crucial, but for things like fetal development, we just don't know. Some concepts suggest maybe having a rotating space station in Saturn orbit, providing artificial 1G gravity specifically for raising children, at least initially. Psychologically, making habitats feel less like sterile labs is vital. Integrating plants, maybe using biophilic design principles, having common areas involving colonists and planning, all crucial for community well-being on such a remote outpost.
And the suits. Even if they don't need pressure, designing them sounds like a huge challenge.
It really is. Designing a suit for -180 Celsius, surrounded by flammable reactive hydrocarbons, it's tricky. One idea is a lighter, actively heated suit. Maybe an internal mesh of microwires provides warmth with a very low conductivity outer layer, but it's complex. Any contact with the super cold ground could potentially cause the liquid hydrocarbons to flash boil a sort of thermal explosion, and you have to worry about oxygen leaking out of the suit and creating an explosive mix with the methane atmosphere. It's like designing clothing for walking around inside a tank of liquid nitrogen. Materials have to withstand extreme cold without shattering, and the seals have to be absolutely perfect.
Wow, this deep dive really shows Titan isn't just some distant cold rock. It's packed with these incredible paradoxes, isn't it? Extreme cold, but a thick, protective atmosphere. Liquid lakes, but of methane, not water. It challenges us in completely unique ways.
Absolutely. And connecting this to the bigger picture, all those organic molecules, the energy sources, the potential for liquid environments, it makes Titan incredibly compelling, not just for colonization, but for astrobiology, too. There are even calculations suggesting that biological processes, if they exist, could potentially contribute to keeping Titan slightly warmer than it would be otherwise, hints that life might already be subtly shaping the moon.
So the big question remains, will humans actually build a thriving civilization on Titan someday? Will we be sailing methane seas, tapping into that hydrocarbon bounty, maybe even finding new kinds of life there? The journey is incredibly long, the challenges are immense, no doubt about it, but the potential payoff, scientifically and maybe strategically, it could really reshape our future in the solar system. Perhaps humanity's next giant leap isn't onto red soil, but onto a rich, hazy orange world.